Thank you, Jouni. So I'm Mika Karaila. I'm working for Valmet as a research director, and I'm also here at Aalto University as a professor of practice. I will have the course about the industrial internet. But a little bit what I have experimented. So I'm using the Claude Desktop Pro, and it's using the Sonnet 4.5. I implemented fast MCP with the Async UA, so it's a good performance. I have here overview, and then I actually implemented perhaps a little bit more than those tools that are listed here. I have some examples and summary at the end. But how it actually works. So what is MCP? So there are a lot of those MCP servers available for the Slack, Gmail, local file system, and databases, GitHub. And I implemented prototype that contains the OPC UA MCP server, and then also a little bit what to do with the data that I can fetch from there. I implemented small anomaly detector. It's not so great, but working, and also the small forecast MCP server. So it took some Finnish perkele. It wasn't first so easy to set up, but I finally got it working. So I can just say prompt connect endpoint name, and it will connect to OPC UA server, then browse. It will browse the address space and find variable, let's say what I was using, the process simulation server. I just say find the sinus or counter, and then other things. And so I tested it a little bit, and that was the first time. So I get the information there, the server information, the nodes and the simulation data and the static test data, those folders that the simulation server contains. Looks great, okay? And then I made also the how to visualize it. So it was creating on the fly the small report web page that actually show the data, but that doesn't look very good. So I actually then took a little bit, implemented a little bit more monitor or subscribe variables, but I wasn't satisfied with that one. So I actually added there also those aggregates and the historical data access. So you don't have to store the data to cloud or anywhere if you have a small snapshot of the time series data. So you can actually fetch the data directly from the historical access, the amount of data that you need for your functions. This was just to test the aggregates. And I then added actually the little bit more those min, max, and average. So it actually depends on the server what kind of the historical data access aggregates it can provide. But I added then they're actually all possible. And it was nice to test everything that you can actually then run a little bit like the data scientist analysis for already with the historical data, those aggregates. Okay, but as I said, I have the anomaly detector and forecast there. I started to test about what was the simulation variable with the random historical data, what it will find out, the metrics and anything else from that, making the analysis or the anomaly. So the results were quite interesting ones, but the random function is working great as expected. But that was just testing the anomaly detection and the summaries here. And so this was not enough. So I started to play also with the historical data, the forecasting, sinusoid function, and it actually finds quite nicely the different features and also the periodic data. So it was also good to visualize it. And that was actually nice to find that it really finds out the period, the format of and making the perfect match for the forecasting. So that was actually good to know that with such features MCP server with certain Python functions, you can already implement this. And this is actually the little bit what I want to talk a little bit more. So we can actually connect those different data sources for collaborative AI, and we have the knowledge management then on the next level. And we don't need to copy and store the data all the time, the time series data. We can actually use it on the fly, like we can talk to time series data and use it for the different kind of analysis. The current prototype experiment is just something like 600 lines of code, and I actually implemented it also with the TypeScript. I'm somehow the multi-language coder, and I want to check which one is the better for this kind of implementation. But I actually implemented already some security features, the username and password, but the certificate I would like to add there before I make this open source implementation, because the certificate is needed if you want to run it remote MCP server. You have to encrypt the data when it's going over the internet, for example. And analytics and forecasting, they are not the production ready, they are just the prototypes, just to show that what you can do with the data. And I actually find out when I connected our Valmet OPC UA server that with the prompt, you cannot actually avoid the mistakes. So we are actually I'm going to this context engineering. What you have to return, what the MCP server should return to you, because otherwise you have the context overflow. And there are different kind of the things what you can do. You can actually make the tools just to return certain amount of data, but those skills for the agent, they are the good solution. And if you want to find out a little bit more, you have to Google it and read a little bit more about the articles, what the skills can do for the agents. But they are actually fixing the problem that you will face with when you are actually using it in the production. It's kind of if you have a PDF document and you want to find out from some machinery document the spare parts, you can actually read table of contents, look the pages that contain the spare parts. Pages 50 from 50 to 56, they will contain the spare parts, and your agent will read only those pages and return the spare parts that you should use for that machinery. And I think we will actually continue the research and then also the development and the kind of the agentic AI platform, our DNA-E, that we can actually then mix and match different agents. But it actually, with the small amount of agents, you don't have to care so much. But when you are building up the larger MCP server farm and the more agents and using those together, then you have to have certain rules that will be actually over the system or over the platform consistent. But actually I don't have to do only for the cloud. I added 2 lines of the JSON, the configuration that the MCP server are used for the cloud. So I don't have any fixed configuration there. So I can just use the prompt connect, browse, find variable, run anomaly detection, make forecast and visualize. Just 5 commands for the LLM, and that makes everything. Yep, that was my presentation. Now, questions?
Thank you, Mika. Very concise as usual.
Sorry.
No, it's just. Yeah, yes. Good for a change.
But I promise I will make it open source, as I have fixed a couple of things. I want to have the discoveries there and the certificates, then it's ready for the prototyping. Yes.
Yeah, so it's a proof of concept.
Yes.
Any questions, comments?
So So when you were predicting this or doing this predictive thing of future, like of course the sinus, wave is quite easy, but did you try to do it for any real process data? And because we have been trying to do that, and we have been struggling, especially with like that the AI doesn't understand the changes in the set points. But if I wonder if you had similar experiences.
I actually talked during the coffee break with Papis man, okay, not here now. But the problem is that those existing foundation models for the time series data, they are trained with some other data than our factory or mill data. And now the AWS has actually launched the Nova, that is the partly pre-trained model, but you can actually train the model then with your own domain data. And I think that would be the solution, because then you can have the process-specific, the final training is done with the data that is coming from that factory, and then the model will fit for that factory better. But of course, the problem is that if you take the process data that is controlled by our system, then it will actually make the prediction or the forecast how good our controllers are. So you should have also the open process model in the time series data. What happens if you have some device actuator is not working? What will happen then? And can you actually use some other actuators, the pump or the wall, to fix the problem in the process? But that's the complicated thing. Yeah.
Any more questions or comments? I can add that of course we know from the past that predicting is difficult, especially predicting future. And the AI is not much better than people in that if it doesn't have a good source of data that already behaves the same way that the future will behave. So of course it always boils down to the data that you use to train the models, but that's where where AI can of course be better than traditional models, because mostly the problem with traditional models is that you need to create the mathematical model for the process.
Yeah, but
and if you cannot do that, then AI can figure it out automatically from the data. But then you really need to have good data for that.
Yeah, but there are also those zero-shot machine learning models that you are not actually using the normal data. You are just using those where is the anomaly or the event. And then you can actually multiply that most probably for other machinery or the other processes also.
Yeah. Like Pyri mentioned, we also did some experiments. We had a master's thesis written, just finished recently, and that's from Artturi Korhonen. If you want to look that up, from Aalto University, he was checking out the available AI algorithms for anomaly detection and prediction, and went through all of those and found the ones that work the best and fastest. But there seems to be a lot of attempts going on, and that's already interesting on its own. And maybe we will try to bring that also available somehow together with Forge, which is our application that tries to enable all these OPC UA fancy features on top of basic features, and also maybe some tools to play with the AI algorithms in future. So just contact us or Mika if you're interested in any of these topics. Okay, so then we move on to the next presentation.